Okay, so thank you. The conference start. So we are Rafael Flores and Michael Allo. So Rafael Flores here is the main developer of the WheatIS DataDiscovery tool. And myself, I am the leader of Wheat Data at URGI. We are both working at URGI. So I will now present you very briefly the outline of this webinar. So we will start with a very brief description of the WheatIS project. After that, we'll present you the architecture of the WheatIS Data Discovery tool, also the different data providers, and how to exchange the data within this tool. After that, we'll have a first question and answer session. And after this session, we will show you a live demo of the tool, and then describe you how to contribute to this tool and on the perspective on what we are working on. And we'll finish with a second Q&A session with all your questions after this demo. So during this webinar, please ask your question in the chat, and we will read this question during the Q&A sessions. So the WheatIS project was launched in 2011 following the announcement by the ministries of European countries. And so the WHEAT initiative provides a framework to help the wheat research at the international level. In this WHEAT initiative, some expert working group have been created, and the WheatIS Expert Working Group is one of the first expert working group which was endorsed in 2013. So at the moment, the leadership team of this WheatIS Expert Working Group is Tanner Sen as chair, and Adi Kesneville, Mario Cacamo, and Dave Edwards as co-chairs. So basically, the WheatIS project wants to build an international information system to support the wheat research community. The main objective of this information system is to provide a single access web-based system to access all the data, all the open access data available on the community. So there is a website, wheatis.org, with a lot of links on this website, as you can see here. There is all the description of the WheatIS project, the member of the WheatIS Expert Working Group, but also links to guidelines to help you to have the standards of all the wheat data. And the search tool, and we'll discuss the webinar about this tool, which allow you to search keywords in all the wheat data across the world. So now I will give the microphone to Rafael.
Hi everybody, thanks for attending. So as Michael said, I'm going to present the WheatIS Data Discovery architecture, how we designed it. As he said, it's a project which started back in 2013. And we started with a group in Europe at the beginning with colleagues from Australia also. And initially we used a Solar tool, which is this one, to share the data. You have on the left side a list of some data provider from France, United Kingdom, Germany, Australia, Mexico, and United States also. Each of them can provide data in several manners, from storing on RDF triple store, legacy databases, flat files also, and using Solar tool. The first step is to provide data under TSV. So each partners of the federation, WheatIS Federation, extract its public data into TSV file, and contact us so we can take this file and integrate further. So one of the first step with this TSV file, tabulated file, sorry, is to convert it in JSON, and as you can see, there is a normalization step which allows us to remove duplicates and to also normalize data following same logic between all the different data providers, for having a good display in the web interface later. So these JSON files are stored under Git at URGI using a large file storage feature, which is also used on GitHub for people who knows. So we store the JSON file and we are processing it further to generate a suggestion and JSON files which are also stored on Git LFS next to the JSON data. This process is done using Bash and a GNU parallel on a Unix system. The next step is to index this JSON data. So for this, we still use Bash, GNU parallel, and GQ. GQ is a JSON processor usable in command line. So we are transforming the JSON stored on GitLab for being harvested into a search engine, here Elasticsearch. So Elasticsearch is used as the backend, the data store for the WheatIS web application. So the WheatIS web application queries Elasticsearch as a main web application query databases. And the web application itself has been developed using TypeScript, Angular for the web interface, and is backed by a web API powered by Spring Boot for the technical parts. I'm going to present more in details what each data provider provides in terms of kind of data. So to begin, we have URGI, which we are providing genome annotation, gene annotations, physical maps, repeats also, and some bibliography from a project open-minded here. EBI has been indexed also, ensemble plants mainly, and we have mainly genome annotation. IPK provide data also, and Grameen has given to the WheatIS Federation mainly genes, as you can see here, but also gene ontology information about processes, functions, components, and so on. The 3CC toolbox provides mainly markers and from maps, GemPlasm also, genes, phenotyping experiments, and genotyping experiments. As you can see, they also provide proteins data. If you look at the database provided by 3CC toolbox, you can see that UniProt is under umbrella of T3, because I have made an effort to index wheat-related protein from UniProt and give it into the WheatIS Federation. University of West Australia has provided wheat pangenome data and also bibliography related to the pangenome. South Green, which is a French platform provides gene annotation. AlgoLD is backed by a RDF triple store, for instance. Colleagues from Rotham State Research in United Kingdom has provided gene annotation extracted from their NetMiner database. UNGenes provide germplasm, QTLs, genes also, and several kinds of maps. And here again, you can see that UNGenes has given to the WheatIS the wheat gene catalog from Komugi in Japan. So in the same manner as UniProt by Tetra, you can see a wheat gene catalog from Komugi under GreenGenes umbrella. PGSB from Germany has provided also gene annotations from Crow's Nest database, and CIMID from Mexico publications and datasets. And IPGPass from Poland is providing also phenotyping studies. All this data is related to wheat only. So how did they do that? For sharing data within the WheatIS Federation, we have defined an exchange format, data exchange format, which is quite simple. It's mainly 7 fields. I'm going to present you. The first is the name of the feature, which allows users to identify easily the reference to resource in the WheatIS interface. A URL which is used to link back to partners' online database. This URL must be dereferenceable. The description fields contains all the keywords allowing users to find a given resource, and also is a support for describing more detail each resource. The entry type is the kind of the data. The species can be multi-valued. Here you can see the cardinality, and is used to reference all the species related to a given entry types. For a gene in general, it's one species, but for trial in fields, for instance, we can have several species which are sold in the same time. The node here is a provider of the data, it's the institute who provided the data and integrated in the WheatIS. And last, the database name allows to know what was the database from which the resource has been extracted. There is very few constraints on the data. The name must be unique among a given dataset, and the species here, the species list is expected to be one of the 4 described here: Aegilops, Odeum, Triticum, and wheat. So if people provide data which is not part of this species list, it won't be displayed in the WheatIS interface. But as I will show just after, it can be of interest also to provide non-wheat related species data, because it can be accessible on another flavor of the WheatIS. More to go in few seconds. The format of the data must be JSON files or tabulated files, as you wish, following this the data exchange format. Each colleague can provide these files, flat files, via HTTP or FTP servers, as you wish. And legacy and historical partner also provides some of its data using a Solar node, which is supported only for historical partners. More details are available on this URL, explaining how to fill each entry, and with example for JSON and TSV file. So as I said, there are several flavors of the tool, the data discovery tool. We are speaking mainly about the WheatIS today, but as I said, we can have plant wall data with Brachypodium, Arabidopsis, and other plant data, non-filtered by wheat. It's available under this URL if you want to go to see. you will find all the data which are available in the WheatIS portal, but also non-wheat related data. And the last one was a dedicated a flavor dedicated to genetic resources developed in the frame of a French program. Okay, I'm going to move under the wheat.
We will take the question now.
Yes. Absolutely.
So before the demo, please, if you have some question about the architecture, the formats, or the WheatIS projects, feel free to ask them. And after that, we'll answer briefly this question, and we will go to the more interesting part, the live demo. So feel free to enter your question in the chats. We will wait 1 minute to let the time to people to write the question in the chat. Okay, so we have a first question. So the question is from Nicola. So I will add it in the chat. So the question is, do you have data of trials that contains also pedigree and environment information, such as location or years?
It's up to each data provider to fill the description field, for instance, and each provider of data can choose if he wants to add more or less data. So if we have a trial experiment fields, we can decide, a data provider can decide to add such information, but if it's geolocation, it won't be really useful, because we don't display a map to see easily where the field has been held, for instance. But there is no constraints on the description field, so if any data a data provider thinks to be relevant can be added into the description field.
Okay, so second question from Bokor Firtisa. How can I sign up for the login? I tried but couldn't.
What login?
So for the WheatIS data discovery tool is fully in open access. So I think you haven't any login to enter for this tool, but perhaps you try to connect to other resources we propose at URGI. For example, if you want to access the reference sequence or so on, but it's for the WheatIS, it's only in open access, so no need for a login. Another question. Please, what is the difference between nodes and databases in this tool?
Yes. Node is an institute who is providing data into the WheatIS Federation. So you can see there is ABI, Grain Genes, Gramine, INRAE-URGI, and databases are the web application which is storing data and on which we can use backlink to display the source data. So the data provider is more the institute, and the database name is the web application providing the service.
Okay, another question from Sean Quinn. Is there any NGS data from any wheat samples, FASTQ, BAM, including in the portal?
So the portal is a data discovery tool, so we can give access to BAM, FASTQ, and so on using a file link. So it's already done. If you look at some file data for CEMIT, for instance, I don't know if they provide FASTQ, but they provide data files. So if you have a service like Dataverse, DSpace, or even a web server, you can provide a link to this file and integrate it into the WheatIS. You have to provide only the data exchange format with additional information allowing to retrieve this FASTQ. So mainly with the metadata, the species, the entry type, and a few description allowing to find the given files.
Okay. Another question: is there any obligation to use wheat data by the scholar by this tool? I think. No, I think you already discussed that.
I'm not sure to really understand the question, but we can provide non-wheat data. It will be displayed in the data discovery, plant data discovery, but not in the WheatIS. If the species field is not filled with Elgilops, Ordium, or Triticum information, it will be filtered out.
And another question: is the China Spring wheat reference sequence version 2 a freely access as well? I can answer that because I am member of the INRAE-URGI coordinating committee. So we hosted at URGI the reference sequence. So at the moment, the version 2 of the reference sequence is not in open access. But you can download it very easily using our resources at URGI just with signing of a Toronto agreement. And the annotation of this version 2 is in progress. So when the annotation will be available in open access, we will add it to the WheatIS as we have the IWC V1 at the moment. And I think that Raphael will show you this in the demo, so perhaps we could go forward for the demo.
Yeah. Okay, just zooming in out. I have to reduce the size of the. Okay, looks good now.
Looks good.
Well, okay, so just for me, I'm going to reduce a little the zoom.
It's okay.
Is it good for everybody? If needed, I can zoom in again. So you have here the homepage of the WheatIS search data discovery tool. So it's a Google-like application. You have a reminder of the data provider on the left side, which I described in details in the slides. So I won't go back in that part for now. We have information, useful link to the homepage to the WheatIS website. Michael talked a few minutes. A link to the WheatIS initiative, which is at the source of the projects, and data to WheatIS. The more menu allows to have information about how to use the application with a few information I can mention, and detailed details about how to join the WheatIS federations. It's the link I mentioned in the slides previously. So the main page allows to enter any term we are interested in. If we are looking for information about marker, for instance, you have a sample here with yield and FHB. I will come back to that later. But if we look at CFD, you have auto-completion which is available. So as soon as you start to enter something, starting with 2 characters only, you have a completion which suggests you something which could be relevant for your search. So there is no limit upper, so we can continue to enter characters to get information. So if I select CFD2, I click search to get information. So we have the result page, which where there is a reminder of the search information, so CFD2. If you want to search another element, we can also CFD and suggestion still works at this moment, and don't click search. We have a list of results in the main area, in the central part. So you have one result here, which you can see the name of the document. It's not very useful here because it's this feature has no real name. It's not a gene, for instance. So it's a position on a GBrowse. You see the database here from which the data has been extracted. And you can see for each document the type of the document. It's a gene annotation and the list of species in a web page here. Here we have a document which is related to only one species. And the description part is visible here. If it's too long, we can expand it or hide it. As you can see, there is highlights available, which allows users to identify easily why the document has been selected. So we have about 20 results per page, and we can, if we want, there is only 11 results here. So there is pagination implemented. We will see it later. On the left part, we have information and filters, which allows to restrict the results on several categories. We can filter using species field, data types, database, or data provider. There is a problem here because we don't have enough data. Okay. So as we can see, we have a filter. We can filter on Triticum aestivum, Aegilops or Triticum aestivum. As you can see, there is some redundancy here. There is some work again to improve this part to avoid to have several aestivum, for instance. There is no constraint on the species field, but we try to have the same logic between data provider, but there is still work to do. We can also restrict on data type. So if we want to look at markers, for instance, I click on markers here, and the results part is directly updated to have only markers type data. So if we go to this backlink, we will get on the GNPIS system, for instance, which is okay. It has loaded. Is it visible? I zoom again.
Yeah, zoom please. Yeah, nice.
Okay, so we have information about this marker, the mapped loci where this marker has been identified, and other cross references. So it's a link to the GNPIS, but we should have links to other databases also. Sorry. It's a good way to introduce this web application. You can use it on mobile devices also. If you are on a mobile, the display will be updated according to the size of the device. So we have filter parts on the top of the page, and below we can have the snippets for each document, 1, 2, and so on. So if I zoom out, I will come back on the computer visible. Okay, so it's better now. Okay, I will remove the marker feature, and if we look, we can use several filters to restrict on data. If I click on gene annotation, by default we have 11 results. If I click on gene annotation, we will display only that kind of data, 1, 2, 3, 4, and we can also restrict on bibliography to have results related to both entry types. So Since there is only one entry type per document, the result will display both of them, the 4 gene annotation documents and the 1 bibliography. So we have 5 documents in the result page. So it works like, in this way for the same category, but if I remove this bibliography, for instance, and gene annotation, if I'm clicking on Criticum ISTVOM, which has 8 results, I can do another restriction with another category. If I click on data type, I will only get documents which are gene annotation and which are related to Criticum ISTVOM. So we should have only 4 results, and it's a result of the intersection of the species facets and the data type facets. In contrary to inside the same facet, we have the union of the both selected facets. We have 8 Criticum ISTVOM and 1 Aigilops Toshi results. So if I go back, so we have here, for instance, information on gene annotation. If I open it, I can get a GBROS view to answer the question which has been asked earlier. We are looking at the EWSC RefSec annotation, for instance. Is it visible? No, it's not very visible.
It's okay.
I'm zooming in. Okay. And we can see that we have the CFD2 marker, which is visible here, and we have annotation high confidence gene here, which is visible. If I do a right click, I can have a backlink directly to the WheatIS for this specific feature, and also as WheatMine, Ensemble Plants, and another tool named Persephone. If I open the details of this gene, I have information on Go annotation, which has been done for this feature, and sub-feature which are located next to it. So mRNA, for instance, and so on. As you can notice, we have a backlink to the WheatIS for this feature specifically. So it's a gene name. If I click on it, it's open a window on the WheatIS with a search already done for this. So for this gene, we have 3 results. No, the one from which we are coming, EWGSC and GNPS, and also 2 other results from NetMiner in United Kingdom and Ensemble Plants. If I click on WheatNet, I open the Wheat NetMiner instance, and we can have more information on. Is it visible?
Yeah.
Yeah. On the given data. I will zoom in.
Yeah.
Okay. Sorry. Okay. So here we can see in the context of the gene, we have a lot of information. We have some traits related. Here you can get some information. You have a backlink to crop ontology. Yes. We have a description for each feature related to the gene. So it's a knowledge graph which give very interesting information related to this gene. So if I come back to the WheatIS for the same gene, I have a link to Ensemble Plants, and which opens the EBI web application, Ensemble Plants. You have information for this protein, for instance, and you can go on further analysis in the Ensemble Plant tools for this gene specifically. Okay, so if I come back to the WheatIS home page, okay, I can make a search for instance, a yield, and I will get data for yield related information. Thank you. As you can see, the filter on the left side has been changed because, just let me, okay, is it visible? The filter on the left side is also updated on its display because we have 34 results species for yield keywords. So instead of having 34 checkboxes to look at in the filter, we have decided to implement it as another search box. And so it's the same for species, data type, and databases. And the data provider list is lesser than 10 results. So we see it as checkboxes as before. So for instance, if we restrict on a database, I can enter, we see only the 8 first databases available with the number of documents related for each of them. And I can enter a character to restrict on a database. So if I enter a T, I have on page my TID, SIMID, publication, netminer, and so on. And we are WheatIS toolbox, which was missing before, and which we can see now. So as if I was checking the box, the WheatIS toolbox is now selected, and we have only information from this database specifically. So if I click on a document, it's linked back to the WheatIS toolbox website to see here phenotyping experiment data related to yield, and they also provide genotyping experiments. If I go here, for instance, so here is it's not very readable. I am zooming. Yeah. Okay, we have information. Oops. About a trial, so you get a trial name, the breeding program, location, and so on. So here we have more details in the source application than we have in the description of the documents. If I come back in the WheatIS, as you can see in the WheatIS, the description only contains the traits related to the QTL. And we do not have much more information, but you have the year of the trial, the location in the source. It's up to WheatIS toolbox, for instance, to provide a link on the location and the type of stock used in this trial, and the description. And the description is already copied too. But if the location is also in the name, though. So if we search for Lincoln in the WheatIS, it will match this document. But for instance, Nebraska is not visible in the description, neither in the name. So if we search for Nebraska, this document is not will not appear in the results. So it's up to each data provider to provide more or less information in the description field. The more you provide, the more it's possible, it can be matching with a user input. And also here we are seeing genotyping data. So the description here, I think it was the same as in the, yes, in the WheatIS. So the description has been copied also, but we could add information. If we come back to this the WheatIS, I uncheck WheatIS toolbox, and I can have access to a CIMID publication. So it links back to the CIMID website to display details on the publication. So if we look at the description here, we have mainly the name of the publication, for instance, and information about what has been done for this in this. What was the theme of this publication. So also you have a link to Komugi Wheat catalog, which is provided by GwenGenes, and the link is in the Japan website, and we have information on the wheat gene catalog, and you can go to this website to browse and get more information about this gene specifically. Okay. So I can introduce the pagination information. We have only 20 results among the less 2,000 documents. So if I come to on top bottom of the page, I can move to a page later, and so on. I have the results are paginated, as you can see, as you have the same feature in Google and other search engines. Okay, so if you remember the data format exchange, you have a direct mapping of the filters on the left side and the fields in the document. So you find the species fields which allow to filter on the different species. As you can see here, you have data which are not related directly to wheat, triticum, because some feature can have several species. And as you can see here, in JNPIS, for instance, we have some features which are related to rice, to brachypodium, sorghum, and also triticum aestivum. So it's mainly orthology between those different species. So it's possible to specify several species and get information on the species non-wheat related. Okay, so I think I have made the main description of the web interface. One last thing, I will present briefly how it works just after in the demo. But if I look for blé means wheat in French. I can hit search and I will get information. As you can see, there is a specific processing which occurred here. I entered blé and I have wheat, which is highlighted. Recently, a colleague from us had the ability to search using synonyms about the keywords entered by the user. So we have a process I will present just after, but we can implement this kind of synonymy further if we have several documents, terms, sorry, which are closely related. So it allows to find more documents, but as you can see, we can spread the search among very lot of documents. We have above 20 million documents which are resulting this search, because wheat is very large. But if we search for instance, more specific information, acorn wheat, for instance, there is a synonym which is Triticum monococcum. I don't see it. If you acorn wheat, I think. Acorn. Yes, there is anything. Oh, sorry. Okay, well, I don't remember where is the okay, I got it. So acorn wheat is a synonym of Triticum monococcum, so we can find documents related to this species specifically, and then go to green genes, for instance, and get information on this germplasm specifically. So I have shown documents from green genes. We have also information about for JBs. As you can see, there is no typically for JBs there is no entry type. JBs is a historical partner of the federation, and at the start the entry type was not mandatory, so we still have that document visible in the portal. So here, typically, we are in IPK database, which show information and the passport data for this specific germplasm. Okay, I'm going back to the slides.
Thank you very much for this live demo. Very fast interface. So we'll finish with some slides and then open the second question and answer session.
Just a moment, I found the good slide. Okay, I didn't show that, but I will show in the slide. So to share the good window. Okay.
Okay, it's the beginning.
Okay, it's not the good one. Just a moment. Okay, this one. Okay. The sharing has been lost. Okay, come on. It should be better now. Okay.
Yeah, it's okay.
Well, so I didn't mention it, but each research can be linked back at a later time if you want to share results. As I show in this slide, if we search for yield information and we select a Gramine database and a gene entry type and the Triticum urartu species, we can copy this link and come back later to the web application showing the same results as the first time. So if you want to share data with one of your colleagues, you can copy and give him this filtered URL. So about the synonym feature, how does it work? As before, we have TSV, Solar, RDF, and triple store and database extraction, which allows to share data in JSON format. It's the same as before. But there is another extract transform load process, which starts from, for instance, the WheatIS database. We are storing species information with synonym for each species, as well as at NCBI, for instance, and taxonomy at NCBI contains common names and so on. So we are extracting such information. We have a process for transforming that in a synonym document, which is given to Elasticsearch, and at query time, the synonym is retrieved from the document in Elasticsearch, the database storing the data for the WheatIS application, and we are searching for synonyms also. So when I was entering BLE a few minutes ago, it was looking at this file, for instance, and searching for all synonyms it was finding it in it. I showed that in the demo live, so I won't go back here. And it was a slide with the Encorn wheat and the good without typo. Okay. So the live demo is finished, but there is several things to do in the next weeks and next months. In terms of features, for instance, we plan to implement automatic updates of data. As I mentioned, data provider can give provide data on a web servers. But at the time of the webinar, the process of fetching it and transforming in is still manual. There are routines to transform the data, but there is no check on a regular basis for new data, for instance. So it's something we plan to do. As you have seen in the first slides, data is currently stored next to the code in the Git repository. It's very useful for starting with the application, but we have much data now, so we plan to move the data away from the Git repository to ease the usage of the source code. We plan to improve performances mainly by moving our hardware and infrastructure and having a dedicated virtual machine in on-premise cloud at INRAE, for instance. We have some cosmetic improvements under the hood. Tanner already spoke about that a few weeks ago. And we plan also to implement a feature to enrich research by ontology enrichment. It's not something which I can display at this time, but the main idea is to, for gene ontology, for instance, if a user enters a Go term or a Go related term, so for instance kinase, we will display him a new facet on the left side next to the other, and with Go terms related to the kinase keywords. You will be able to search in these facets and to restrict a given gene ontology term, and it will search with specific gene ontology terms, and potentially, if the user decides to select it, with also all the sub-elements of this gene ontology, which allows to identify document and enlarge the research to more data, more ontology term. It's something we are trying with the gene ontology, but if it works and if the user interface is useful, we plan also to use other ontology in the future.
Like thread ontologies and
yes, exactly. And for the data part, we are on discussion with GreenGenes, for instance, to provide new data in the next week. For instance, Victoria should provide 70 map data and 3,500 QTLs also in the WheatIS, so related to it. So it's welcome, very welcome. And in our part, we plan to index and integrate the WheatMine of the EWGSC wave seconds in the next few weeks also. The question is about your data. If you have a web service or data you would like to implement in to make visible in the WheatIS, you are really welcome to contribute. And you have two possibilities for contribution. You can contribute to code. The web application is available under BSD-TRA open source license. It is available on our intern GitLab instance. The link is here. It is publicly accessible. If you follow this link, you will see, you will gain access to the world code source code and also the data at that time until we move the data elsewhere. In this GitLab instance, you have information in this README file, for instance. There is a link behind it, which explain how to install and run locally the application. And the contribution are really welcome, very welcome. If you want to help us to make the tool evolving, you can contact us, and you have indication in this guideline to how to work with us to go further. And for the data counterpart, again, you have the link to the how to join federation, which explain how to format the data and how to have to provide it mainly web HTTP or HTTP. So do not hesitate to contact us at this email contact or via the website. So last, if you have a few messages to take home, WheatIS is a federation of wheat data repositories for public data discovery. It is using a simple and generic data model with 7 fields, which could represent data from any database. It is open source and use state-of-the-art tools, languages, and frameworks, and it's very easy to join. You just have to provide a TSV or a JSON files if you want, and contact us. Thank you for your participation and your to our attendees.
Thank you very much, Raphaël, for this very nice talk. So please ask us some question in the chat. We'll have 5 minutes remaining only to answer to the question, and after that we will close the webinar. Before the question, I would like to thank all the people who contribute. It's a very big team who are working on this tool. There is people from INRAE-URGI here, but also all the data providers, also all the people from the WheatIS initiative, and especially the people from the WheatIS Expert Working Group. And you can contact us using emails, using Twitter, and also we are currently under the writing of a publication about this tool, and since then you can cite the last publication. So now I will take the questions. So first question: is it possible to have a list of gene ID in scaffold format and their equivalent ID in RevSec v1 format? Because we have problem in using software like String, which use scaffold ID.
So I don't know about String software, but the main objective of the WheatIS is for data discovery. So we don't plan to provide a list of gene ID, but the tool which are referenced in the WheatIS should be able to provide to give such feature. So if you go to, for instance, the WheatIS GBoard, you should be able to get track by track a list of the scaffold IDs, I think. And I believe there is such export feature implemented in several information systems referenced by the WheatIS search tool. So it should be possible, but outside of the WheatIS specifically.
Perhaps one day we will implement the possibility to download some results, the results in the WheatIS, but it will be only to have all the links and all the names and all the links. It's not a tool dedicated to do that. It's more like a Google tool. Another questions. Thanks for the presentation. Do you plan to directly link WheatIS output to analysis tools?
So at this time, it's not planned. What kind of analysis tool do you think about? Because we only provide links to databases, so same answer as before. I think it's more the responsibility of the reference databases to provide such output, because we don't provide we don't give access to sequence data, for instance. It's more the referenced services in the WheatIS, referenced by the WheatIS data discovery tool to provide such feature, in my mind.
Yeah. Another questions. Is it possible to provide an online tool in the database for drawing gene location on each chromosome? For example, I have a list of genes and I want to have a pic of the location of relevant chromosome.
So there is already software and databases which are displaying such information, and they are doing that in a very efficient manner. So we don't plan to re-implement such work. I know that several USCSC genome browser, I think they provide such
UCSC, yeah. But we can add link to these tools in the WheatIS if the partners want to send us their data, and we can put link directly on tools with zoom on the interesting region if it's an association peak or on genes, as Raphael showed you in the IWC JBrowse. The link is directly zoomed in the matching region of the name of the marker, or it could be a gene, it could be another thing. So I think we are running out of time. It has been 1 hour for this webinar. Yeah. So thank you very much for attending this webinar. We will send you the recorded video and the presentation, so you can read it and also share it if you want. And if you have additional questions, feel free to contact us by email or by another media. So thank you very much.
Thank you, Miguel. Thank you all.
Bye.
Thank you.